In this review, we'll be covering limits. We'll be worried about as they approach infinity and also as they approach 0. First example we'll be looking at is the limit as x approaches positive infinity of the function 5 minus 100x minus 3x to the fifth. Now when we worry about the end characteristics of functions, or what happens to a function as we approach positive and negative infinity, the most important characteristic of a function that determines that end characteristic is the highest power of the function. In this case, the highest power of the function is minus 3x to the fifth. That will determine what the end characteristic is. It doesn't matter what the rest of the function is. So if we remember back to the beginning of the chapter, we can just draw an estimating of what minus 3x to the fifth will look at. If remember, x to the fifth is an odd-powered function, so it's going to be rotationally symmetric around the origin. So it's going to look something like this. Now, because it's a minus 3x to the fifth, it's going to look something like this. The minus is going to be cause it to be symmetric about the y-axis. So we're going to have this. If we follow it down to positive infinity, it will keep on going down. So the limit as it approaches positive infinity is going to be negative infinity. The next example we're going to do is going to be similar, maybe a little bit tougher, but we're going to go about it the same way. We're asked to find the limit as x approaches positive infinity of the third root of 3x to the seventh minus 4x to the fifth all over 2x to the sixth plus 1. Make sure that all gets inside that third root. Now we can rewrite this, if we review our laws of limits, as the third root of the limit as x approaches positive infinity. We can move the limit within the root of 3x to the seventh minus 4x to the fifth all over 2x to the sixth plus 1. Make sure that all gets inside that root. Now what we can do is just like last time, is we're looking for the highest power in the function. But a little bit different from last time, now that we're dealing with a ratio, is we're worrying with about the highest power in the denominator, which is x to the sixth. Now what we're going to do is we can't just separate that and make our own graph like we did last time, because the numerator of the function would also change. So what we're going to have to do is we're going to multiply both sides by 1 over x to the sixth divided by 1 over x to the sixth. The equivalent, we're just multiplying it by 1. So now let's distribute that in to the limit. So we have the third root of the limit as x approaches positive infinity of 3x to the seventh over x to the sixth minus 4x to the fifth over x to the sixth all over 2x to the sixth over x to the sixth plus 1 over x to the sixth. Make sure that all gets inside. We can simplify that down to 3 third root of the limit as x approaches positive infinity of 3x minus 4 over x over 2 plus 1 over x to the sixth. Because those will cancel out to make 1 right there. This will cancel out all but the last power. Same thing here. This will cancel out all but the last power, so we're left with 4 over x, and here we're left with just 1 over x to the sixth. Now what we can do then is, if we go back to our laws of limits, we can distribute this limit for each one of these values. So we're going to move that limit in once again using one of our laws of limits to the limit as x approaches positive infinity of 3x minus the limit as x approaches positive infinity of 4 over x all over the limit as x approaches positive infinity of 2 plus the limit as x approaches positive infinity of 1 over x to the 6th. Move that all within that. Okay. Now we'll evaluate each one of these limits to see what we get. So the third root. So the limit as x approaches positive infinity of 3x. So that limit is just the limit as a polynomial goes to positive infinity is going to be positive infinity minus the limit as x approaches positive infinity of 1 over x, or 4 over x. Now, we're only worried about the 1 over x, and something over x as it approaches positive infinity is 0. A really big number in the denominator will cause it to go to 0. Now, the limit as x approaches infinity of 2 is just 2, plus the limit as x approaches infinity of 1 over x to the 6th, same thing as this one right up here, is we have 1 over x to the 6th. So it's 1 over a really big number, we can think of it, is 0. So this is now equal to infinity minus 0 is still infinity, over 2, infinity divided by 2 is still infinity, and even the third root of infinity is still positive infinity. So that is our final answer. The next example we'll be covering will be similar. The next example we'll be covering will be similar. We'll ask to find the limit as x approaches positive infinity of the function 2 minus x all over the square root of 7 plus 6x squared. Now, like last time, we can't just move the limit within the square root. It wouldn't do us much good, because the main problem here is the denominator, which would affect our n characteristics. So what we're worried about now, just like last time, is that the highest power in the denominator. Now, just by looking at it, we see that the highest power is x squared, but we notice that that's inside of a square root. So we know that the square root of x squared is equal to plus or minus x. Or it can be rewritten as the absolute value of x. So what we're going to do is we're going to divide both the top and the bottom by the absolute value of x, or the square root of x squared, whichever is more convenient. So the top we're going to multiply by 1 over the absolute value of x, and the bottom we're going to divide by 1 over the square root of x squared. Now right away we know that we're dealing with as we approach positive infinity. So since we're approaching positive infinity, we're only worried about positive numbers. So a negative x isn't even possible in the characteristic that we're using. So we can just assume that the absolute value of x is the same thing as x. So factoring that through, we get the limit as x approaches positive infinity of 2 over x minus x over x over the square root of 7 plus 6x squared divided by the square root of x squared. Now if we go back and review the beginning of the book, we'll remember that a square root over the square root can be simplified to a single square root. So we'll get the limit as x approaches positive infinity of 2 over x minus x over x over the square root. And I'm going to put that inside of the square root and also distribute it at the same time, so we get 7 over x squared plus 6 over x squared. Close that up. Okay, and now let's simplify our fractions. So we have the limit as x approaches positive infinity of 2 over x minus 1 over the square root of 7 over x squared plus 6. Now, just like we did in the last problem, we can distribute through the limit. So we'll have the limit as x approaches positive infinity of 2 over x minus the limit as x approaches positive infinity of 1 all over the square root of the limit as x approaches positive infinity of 7 over x squared plus the limit as x approaches positive infinity of 6. Now, we'll take this and the limit as x approaches positive infinity of 2 over x, so 2 over a really big number, is equal to 0. The limit as x approaches positive infinity of 1 is just 1. The limit as x approaches positive infinity of 7 over x squared, or 7 over a really big number, is 0. And plus the limit as x approaches positive infinity of 6, which is just 6. So our final answer, don't forget the square root, that's very important, is minus 1 over the square root of 6, which is equal to the limit as x approaches positive infinity of our original function. The next example we'll be doing is going to be the limit as x approaches positive infinity of the square root of x to the 6th plus 5 minus x to the 3rd. And what we'll be doing in this special case, the special case here is a square root minus a single polynomial. So what we'll do here is what they call is multiplying by the conjugate, which is the square root of x to the 6th plus 5, or whatever inside the square root, plus, before it was minus, now we're doing plus x to the 3rd. Now, in order to keep this in equality, we have to divide by the same thing. X to the 6th plus 5, square root, plus x to the 3rd. We can simplify this down to the limit as x approaches positive infinity of, now if we look at the top here, we have a square root minus a polynomial, a square root plus a polynomial. So what we can rewrite that as, is if we think back to our days of algebra when we were doing factoring, this looks a lot like what a factor out of the difference of two squares. So we can think of this as the difference of two squares and write this as x to the 6th plus 5 minus x to the 6th. You could FOIL it out and you'd get the same thing. Divided by the square root of x to the 6th plus 5 plus 3, x to the 3rd. Now, we're at the same steps as we were earlier. So what we're going to do in our last problems is look for the highest power in our denominator. Now, just by looking at it, we see x to the 6th. But remember that x to the 6th is within a square root, so the square root of x to the 6th is just equal to the absolute value of x to the 3rd. Now, once again, we're dealing only with positive infinity, so we're only worried about the positive values of that, so we're only worried about x to the 3rd. So what we're going to do is we're going to divide by x to the 3rd, or the square root of x to the 6th. So 1 over x to the 3rd divided by 1 over x to the 3rd. Let's distribute that out to see what that looks like. The limit as x approaches positive infinity of x to the 6th over x to the 3rd plus 5 over x to the 3rd minus x to the 6th over x to the 3rd. all over the square root. Now remember to change x to the third to the square root of x to the sixth when we look inside of the square root, from x to the sixth over x to the sixth plus 5 over x to the sixth. Now we're outside the root again, so we have to remember to switch back to just x to the third over x to the third. We can simplify that now to the limit as x approaches positive infinity of the x to the sixth over x to the third minus x to the sixth over x to the third are going to cancel each other out. So all we're left with is 5 over x to the third over the square root of x to the sixth over x to the sixth is just 1 plus 5 over x to the sixth. Close that up. And then x to the third over x to the third is just going to be equal to 1. Now if we distribute this limit in, we'll get the limit as x approaches positive infinity of x, or 5 over x to the third. So 5 over a really big number is just 0. Distributed in within here, the limit as x approaches positive infinity of 1 is just 1, plus x as limit as x approaches positive infinity of 5 over x to the 6, or 5 over a really big number, is 0, plus the limit as x approaches positive infinity of just 1 is 1. So this all comes out to 0.